Okay, Trey.
Well, thanks, Mary Jean. Appreciate the introduction and to see so many faces here, and some I know, some I don't. Tonight, I am here with you and engaging in the session tonight as an enthusiast of physics and science, and I'm someone who loves exploring the intersection of science and spirituality, and am constantly sort of mystified by how eventually over the centuries science does seem to catch up with spirituality, and so I thought from no perspective other than my enthusiasm, there's I don't claim to be a physicist or an engineer, but I have looked up some facts and some information to give us sort of a precursor and a background to discussing the topic and the questions that we'll take into the breakout rooms. So if you'll forgive me if there's any physicists or engineers, scientists online here tonight, and I have any information wrong or inaccurate, feel free to correct me. But hopefully, the information I'm providing is solid information, and most of it is based on a documentary I saw recently called Albert Einstein's Big Idea, Einstein's Big Idea, and it was about his famous formula E equals mc squared, which I imagine many of us are familiar with. At least they've heard it, if they don't even understand much about it or what any of the letters stand for. I only myself knew that E stood for energy. I didn't know what the other letters stood for, but I do now, and hopefully we'll have a better understanding of this formula, which again, what surprises me is only come to us in our humanity, in our society, since 1905. It actually was his theory of relativity that was, which included this formula, that was published in 1915, and that was only just over 100 years ago, 107 years ago, I guess it is now. So it's so interesting how recent it is. And for centuries, Albert Einstein's development of his theory really sort of came from the centuries before him, where men and women all over the world were dedicated. They dedicated their lives to understanding the concepts that underlie each part of this equation. And I'm going to go through that a little bit tonight and hopefully stimulate some conversation for us. So some of their investigations into the nature of energy, mass, light, and velocity provided Einstein with the foundation that he needed to draw his astonishing conclusions about the equivalence of mass and energy. The fact that energy equals mass times the speed of light squared. That's what that formula really breaks down to in words. And that the science, the formula, has been confirmed countless times since its creation, and it continues in the implications of our life today. What I find fascinating about it is, and hopefully you will too, so on the basic level, this equation says that energy and mass are interchangeable, mass being matter, that they are different forms of the same thing. Under the right conditions, energy can become mass and vice versa. And we humans don't see it that way for the most part. For example, how like a beam of light and a walnut, say, can be different forms of the same thing, but nature does get it. So one of the questions is often asked is, why would you have to multiply the mass of a walnut, in this example, by the speed of light to determine how much energy is bound up in it? And the reason is because whenever you convert any piece of matter to pure energy, the resulting energy is moving at the speed of light. And I heard something that if you were to take every single atom in a paperclip and convert it to energy, it would create the equivalent amount of energy as the bomb that was dropped in Hiroshima. You know, as I hold the memory of the devastation of Hiroshima in my thoughts by using that comparison. I don't mean to diminish it, but it's an amazing, powerful thing. A paperclip, the energy in a paperclip could be converted to the power of a nuclear bomb like that. So fascinating. So I'm going to share my screen and begin a little bit of a presentation that I hope is helpful for you. And all right. Is everybody seeing the screen? Thumbs up? All right, okay. So as I mentioned, light and energy is the topic, and it's on this formula E equals mc squared. Let's see if I can get this slide to go. And so the different parts of the formula is energy, which is the E stands for, M stands for mass, and C squared is the speed of light doubled. So that's where that formula sort of breaks down. And as I said earlier, the idea came to Einstein over kind of a progression of ideas over the last 3 centuries. This is how long it's taken, like each element of it. If you watch this documentary, which I don't know if any of you received the link that Mary Jean sent out to the NOVA documentary, but I highly recommend watching it. You can find it in Canada because you can't watch NOVA in Canada. You can find it on Vimeo. It's called Einstein's Big Idea. It's an 1.5-hour documentary, but it's kind of eye-opening. I found it eye-opening anyways. It begins with Galileo and Newton and their exploration of motion and matter and gravity, that matter and realizing that matter is conserved in a chemical reaction regardless of how it is transformed. And I don't know why I have that there, so that must mess up on the slide there. Oh yeah, and that's a copy from another slide. I apologize for that. Go to the next slide. So beginning with mass, and I can't see my notes as very well here. It's the first time I'm trying to do it this way, so bear with me. Okay. The 2 of the people responsible for providing the first critical understanding about mass were these scientists here, Antoine Laurent and Marie-Anne Lavoisier, back in the late 1700s. The matter is always conserved in a chemical reaction regardless of how it's transformed. That nature is a closed system. That energy is neither created nor destroyed, but it simply transforms into a number of different substances. And we may be most familiar with things like solids, liquids, and gases. It's just turned into something different, like water, when heated, is turned into steam. And their true passion was chemistry, and that's how they discovered this information. So they tried these experiments, and they measured them, and they found out that this was happening. After that, so that's kind of was the information that was discovered about mass, which Einstein eventually used a piece of that to put this formula together. And the next slide talks about the energy part of the equation. In the early 19th century, scientists such as Michael Faraday, which some of you may understand, well, so he was from the 1700s. I think I've got some notes wrong here, and I apologize. I'll go by my slide here. Michael Faraday discovered something about energy, electromagnetic energy, that there were invisible lines of force that flowed around electricity and magnets. In fact, he was kind of thought of as mad when he suggested that electricity doesn't flow just through wires, but it flows around it. And a lot of us have heard about electromagnetic motors and things like that. And so we might commonly accept this science now, but back in the late 1700s, he was considered mad for for thinking of it that way. This electromagnetic experiment demonstrated that there were these waves of electricity, that energy existed in waves of electricity and magnetism. And moving on beyond energy, my slide to work here. There was this idea of light and velocity. And it's, again, going back to Galileo and Newton, these experiments that Gottfried von Leibniz and Emile de Chatelet did in the early 1700s discovered that the energy of the object is the function or square of its speed. And the experiment that was done by Chatelet was, well, Leibniz thought about this, and Chatelet kind of did the experiment that confirmed it. She dropped brass balls into clay and measured their impact, and that demonstrated objects' energy is a function of its velocity squared. So she clarified that idea, and this kind of affirmed some of the things that Galileo was considering in measuring speed of light when he was looking through a telescope, and other astronomers too, looking at how light moved at a very fast but not infinite speed when looking at moons and planets. So it was very interesting to discover this movement of light, and it laid the groundwork, again, another piece of the pie or the puzzle, to connect mass and energy and the speed of light together. Going back to light, I'm just going to see here, Michael Faraday, a little later on in the mid-1800s, along with James Clerk Maxwell, didn't get a chance to perform any experiments. They were theoretical, but the idea was that through mathematics, they could uphold the claims that light was just one form of electromagnetism, that light in itself was energy. And if we consider that what is being said here is that in order to convert one mass from one form to another requires the speed of light, then it concludes that light is also energy. I was finding a lot of this fascinating, and especially the understanding that electricity moves at the speed of light. And I never imagined that. It just never seemed that it was as fast as light, but it is, and nothing, well, unless you get into some quantum mechanics or quantum physics, right now, nothing has been proven to move faster than the speed of light. There is some speculation of some other things in the quantum realm that might be the case, but Einstein was able to prove that photons existed, that light existed as particles. And that was his theory when he finally started putting it all together in the early 1900s, that this idea of mass and energy are the same and can be converted one to the other. And that the idea and his belief that light's speed, since it never changed and nothing could exceed the speed of light, this reshaped how he thought about the universe. And he came to realize that energy and matter were equivalent, and how one could be transformed into the other using the speed of light. And this, again, was just theoretical, but it was eventually confirmed. And now it didn't take too long for that to be confirmed, but that was by several, Otto Hahn, Fritz Strassmann, Lise Meitner, and Otto Robert Frisch confirmed this, mostly through some of their interest in chemistry and figuring out how to essentially, they discovered radioactivity using modern physics. They discovered elements such as barium, and proposed an experiment to split an atom, a uranium nucleus. And before they did that, I think it was, sure which one of those scientists decided to just calculate, before they did the experiment, I'm going to calculate using Einstein's formula what the energy output's going to be. And so she calculated it, and they did the experiment. They successfully split the nucleus, and they measured the energy, and sure enough, it was what she calculated it to be. So confirming Einstein's theory. So just bring this information sort of to light to help us sort of have an interesting insight into this notion about energy and light and mass and its relationship with one another, and therefore its relationship to us. So at that point, I'm just going to stop sharing my screen, as I just wanted to give you a backgrounder there that I picked up from this documentary, and then a little more research into this presentation tonight. But I wonder if there's any kind of questions that everyone has for me at this moment that I might address that I wasn't clear about, and then I'll invite us to some questions for the breakout groups. And it was very, very basic and very simplified. It's so complicated, but of course, at the crux of what it all is, I find it very fascinating looking at the question of us being physical beings in a spiritual world. Or being spiritual beings in a physical world, depending on how you look at it. Different folks look at it different ways, but you know, the intersection of spirituality and you know, the physical world and the spiritual world. Any questions? I think I see somebody talking, but I don't think they're unmuted.